Good morning, good evening, good afternoon, everybody. My name is Andrew Dillard, and I am here today talking about my project for this semester's Data at Scale class called Designing an Initial Public Offering or IPO Database Solution. So what is an IPO? When companies are privately held, meaning private entities, individuals are the primary stakeholders of all equity shares, they decide to issue those shares on the public markets like the New York Stock Exchange, Dow Jones, etc. And they serve a very specific financial instrument for companies to get access to capital, meaning they sell shares and the company receives the share price and the stakeholders then either gain or lose value depending on how the share price fluctuates given the market conditions. So when companies IPO, there's sometimes a lot of hype and expectations that surround them. And I'm going to give you an example on the next animation here. GoodRx IPO'd in 2020, and on the first day, they had their shares jump 40% after they IPO'd and raised $1 billion for their company. That sounds great on paper, right? A 40% gain over the price they issued their shares to at the marketplace. However, if we look at their share price from here to date, they got from near $60 in 2020 when they IPO'd down to a closing price as of today, May 5th, at $4.60. So down 91.7% lifetime. I'll ask you guys a question. Do you think that is a good investment? Would you have bought this IPO knowing that their share price would eventually erode 90+% over the next few years? As an investor, I certainly would not. However, hindsight is always 2020, and we don't necessarily have a solution to help us gauge or assess how are these companies going to uh, perform after their IPO. And that really leads us to this project and what this project attempts to do. What we are trying to do here in this solution is develop a database, develop a program that we can apply machine learning to, that we can apply advanced analytics to take historical IPOs and provide predictive metrics to them around share price as best as possible. But in order to do that, we have to set up the back end solution. And part of the problem for today's current solutions is there is not a unified or singular source that will, at least that's publicly available. I'm sure private equity firms and hedge funds have all kinds of tools that we are unfamiliar with, but for the general public, a lot of this information is usually fragmented. It's spread across multiple different data sources from SEC filings, Financial Times, Wall Street Journal, Yahoo News, any of your brokerages. Like there is a wealth of information before these companies go private or public, excuse me. However, there isn't one singular data source that marries them all together. When you do find those sources, they're often limited in scope. They don't have the robust data metrics that we are hoping to capture in this project, like you would want to build a model around. They're often limited to what's the expected share price, how many shares are going to be issued. There is no historical benchmark to other companies that are similar to an IPO company or an upcoming IPO company. Accessing these data sources is often expensive. You usually have to pay a fee, or you have to go to Harvard Business School to use their academic credentials to log in. I don't have those, and a lot of the general public does not as well. And I touched upon it just a moment ago, but they're not predictive. They don't tie in historical IPOs. They don't attempt to provide any predictive nature to them. The saying within Investive is, past price is not indicative of future performance. We're going to try and break that mantra. We're going to try and understand, is there a way, or does it even make sense to tie these things together? And can we get to some sort of predictive outcome about these companies? So to do that, we kind of start at the top of designing a database here. It really brings us back to the CAP theorem around consistency, availability, and partition tolerance. For this particular solution, we're really only able to choose two of the three. And if you were to choose two, I would have chosen consistency and availability around partition tolerance. We want this database to be accurate. We want it to be available in real time for investors to make really informed decisions And that leads us to kind of prioritizing consistency and availability over partition tolerance when thinking about the solution that we're going to talk about on the upcoming slide, which is a NoSQL solution here. I just touched on it, but our database is really a key value wide column NoSQL database solution, and there's a lot of different reasons for that. In traditional design, the rational databases are usually a fixed schema, so we can't adapt the tables and structures without a lot of work that goes into it. One of the benefits of this proposed solution is it's scalable. It allows us to add additional fields, which you'll see in upcoming slide. We've already kind of outlined on the plan for this particular project. Um, there's a more flexible schema. So you don't have to keep columns in a similar order. You can move them around or move them out if needed. And all of this really ladders up together into getting to that more accurate decision-making process. We really want to be able to provide fast, accurate, near real-time information that allows the general public investor to decide, is a particular IPO opportunity based on kind of the machine learning and advanced analytics that we would apply to it, really the best decision for me in my investment journey. And that will be individualized to each individual investor. All right, moving on to the next slide. So as part of that database development, you have kind of two values here that kind of tie in some of the additional code book that we worked on in the beginning of this semester, and really kind of beginning to marry those two up. So we wanted to start very basic and start talking about kind of two different key tables that we want to try to merge together to feed into the ultimate machine learning algorithm for this particular project. And the first table you see on your left here is called the IPO data. Here is some of the data that we've scraped from different websites. We've collected from the SEC filings. We've pulled out of relevant news articles, and they really are, what is the expected ticker of the historical IPOs, or what is the ticker of the historical IPOs? And this is going to be the unique identifying key. This is the key that's unique to each individual company once it goes public. You'll be able to search for Apple, for example, AAPL or APPL. I forget which way it goes, but you just saw GoodRx on the last page. Like, each company has their own ticker that's unique to that company. And therefore, we're going to be setting this ticker as the primary key across all of the tables here. What is the company name? We saw the GoodRx example above there. What sector are they in? All of these are text fields. So do they operate in the financial space, in the healthcare space, in the automotive space? Those are the types of things that sector and industry are going to understand. When did they IPO? And that's going to be stored as kind of a date value, as a timestamp. What is the IPO price down to the decimal? Did they launch at 32.50? Did they launch at 5.99? Whatever that number would be there is in there. Who is the underwriter? So when these companies go public, they're traditionally underwritten by a big bank. And the thought around this field is, the bigger the bank, kind of the potential for higher success there. If you have JP Morgan underwriting you versus Joe Schmo Bank, like, you would think potentially that there would be more credence to and more survivability for a particular IPO. Now, that thesis has to be tested still, but it's in progress now. How many shares are offered? And that's just a big integer number that has the total number of shares that are being offered at the time. When you multiply the IPO price by the shares offered, you get a number called market cap, and that's the total dollars that this company is currently worth, quote unquote, if you were to liquidate all of the shares today. The price to earnings ratio, how much is the stock price compared to their expected earnings? If the company makes zero earnings or they're losing money, that's a negative ratio. If they're making money, it's going to be a positive ratio. Similar thing from price to sales and price to book, more financial metrics to really understand the financial health of these companies. Given that we want to feed this into a machine learning model, it is important to bring in different intervals for price performance. So we're going to identify a table that brings the ticker and tie it back to the IPO data table, and then bring in the price at intervals of times, 3 months, 6 months, 9 months, etc., to really assess the overall performance of that stock in set intervals that we can then feed into a machine learning model. So a little bit more on the machine learning that we're hoping to get out of this, and you have kind of this word cloud on your screen here, but these are all things that we touched on a little bit on the last slide, as well as some additional things that we touched on a little bit earlier in the presentation that we really want to bring into this as part of the future roadmap here. So management team experience is another one. How long has that management team been in place at this company? When you look at things like the lockup period duration as well, that's usually a period in time where employees who receive stock as part of the initial public offering or beforehand or equity earnings as part of working for that company, how long do they have to hang on to their shares before they're eligible to sell it? With the theory there being as a lockup period expires and people and shareholders within the organization are able to sell, you may see price begin to move down at that point in time. So these are all different things that are on the roadmap, things that we really want to focus on and feed into this model and expand via our NoSQL solution here to really get a better sense and make the model at the end of the day more and more accurate. So knowing that, there are some weaknesses around our proposed model here. One of the things I didn't touch on earlier that I'll mention now is really the backbone of this is going to be an Apache Cassandra backbone from a NoSQL standpoint. And while it is able to handle really large volumes of data and maintain the consistency and accuracy that we looked at under the CAP theorem, there are some downsides to this. One of the major downsides is it really can become um, complex as this begins to get blown out and we add more and more variables to the machine learning model. It also becomes resource intensive. So do you need server time? How much server time? Are you paying Amazon AWS for that or Azure for that? That can increase your cost, particularly if you are able to roll this out to the general public and you gain more and more users using the service. Potentially it could lead to a paid model, but that's way down the line there. Another kind of downside here is really the learning curve around it. When I went out and researched kind of the learning curve abilities for NoSQL and Apache Cassandra, it took multiple weeks of training from MongoDB to really understand some of the approaches and the best practices for using these types of tools. So if you don't have developers that don't already understand that, bringing them up to speed is a potential downside for implementing a type of scenario like this here. And I touched on the complexity of this a little bit more, but as an ever-growing project, it can become more and more complex. So what are some alternative approaches to that? So we can really look at stemming some of these concerns around scalability, the learning curve needed, and the complexity by using kind of off-the-shelf tools that are already available to us. So you could use a distributed SQL database like Google Cloud Spanner or a Cockroach DB, which really takes the traditional benefits of a SQL database, a NoSQL database, and the horizontal scalability there, but really provides a user-friendly, kind of already comfortable feel that a traditional SQL interface would apply to it. So there are additional alternatives that we looked at. I still feel like the current solution as we've designed it will solve most of the concerns and the need case for this particular presentation here, this particular project here. So why are we doing this in conclusion? So at the end of the day, my goal for designing a database solution like this is really to give individual investors like myself and others just another tool in their toolbox that allows them to take advantage of when a company is expected to IPO. And when they IPO, what can we reasonably believe through machine learning and advanced analytics that this company is going to do in the long term? Where is their share price going? Which ultimately leads us to money. What is it all about? At the end of the day, it's about making informed financial decisions and hopefully growing our overall portfolio. So thank you everybody very much. I really enjoyed this class this semester and I wish you all the best.